Welcome to this video on the topic of inequalities. In this video, we're going to have a look at the concept of what is an inequality, and then we're going to have a look at some of the symbols we can use to express inequalities. Now, first things first, let's have a look at two contrasting scenarios. So in example 1 here, we've got every day, Betsy the hen waddles 3 kilometers. And we want to know how do we express this using math. Now, for all of you, you're probably thinking this is a really trivial question because all we need to do is say, let x be the distance traveled per day, and therefore you can write that x is equal to 3 kilometers. So nice and easy. Now, if we wanted to plot that on a number line, what that is going to look like is, we'll bring up a number line like so, to here. So this is x equals 3. So nice and simple. Now imagine that we change the scenario such that it's slightly different. Rather than having a fixed value of 3 kilometers, let's change it to at least 3 kilometers. So example 2 here, we have every day Betsy the hen waddles at least 3 kilometers. So keyword on at least. How do we express this using math? And of course we can use the exact same method as before, and we can say let x be the distance that Betsy waddles per day. So we can rewrite it as x something 3 kilometers. But if we put equals here, the problem is that we're going to be stuck at a fixed amount, but we know that Betsy could travel more than 3 kilometers per day. So what we're going to do is, rather than using the equal sign, we're going to use a different sign, and it's a type of inequality sign, and it's called greater than or equal to. So the way in which we can read this inequality here is x is greater than or equal to 3 kilometers, which means that Betsy the chicken waddles at least 3 kilometers per day. Now putting that on a number line, and what we're going to find is that we cover, so greater than or equal to 3 kilometers, we're going to cover all of this area to the right of 3, but none of the area to the left of 3. So what we've got here is a tool in which we can use to express mathematical models whereby the variable is not fixed on a single quantity. Rather, the quantity can take on multiple different values. So it's at least 3 kilometers in this circumstance here. Moving on, with inequalities, we have 4 unique symbols that we can use to express mathematical models. The first symbol that we saw was the greater than or equal symbol. And what this means is, of course, greater than or equal. The next symbol that we have that we can use to model our mathematics is we've got the greater than symbol. So it just looks like an arrow that's pointing to the right. So this just means greater than, not inclusive of the value that it's greater than. The next symbol that we have is the less than or equal to. Notice that it's pointing to the left and it's got a little bar behind it. And the final symbol that we use is less than. So much like the greater than symbol, the less than symbol it means less than the number that is on the right hand side, and it's not inclusive of that number at all. Now looking at a few further examples, some further models or further situations that we could model are Joe eats no more than 5 Weet-Bix for brekkie. We could say let x be the number of Weet-Bix, and therefore we could write it as x is less than or equal to 5. So he eats no more than 5 Weet-Bix, but it's inclusive of 5. Similarly, Joe spends no less than 3 hours per week studying home math. The way in which we could write this is let y be the number of hours per week studying math, and then y is greater than or equal to 3.